Hello students, welcome to EDUHUNT. As usual, today we learn some concept and then we solve questions. Okay, right. Chalo. Let's move on to the another worksheet, that is 4A. Okay students, do you understand this worksheet? While solving the question, each and every option, not only in mathematics, every subject you should know, then only the subject will be very easy. Okay students. Next, if x, y are any two whole numbers, then x divided by y is, okay. Already I have discussed in the previous question that in this type of questions we have to go through the examples only, then only get the exact answer. See here, x, y are any two whole numbers. What numbers? Whole numbers. Whole numbers means we can take, then x divided by y is equal, that means x by y is equal to, if I take x is equal to 1, y is equal to 0. What do you mean by that? 1 by 0 is equal to not defined. Okay, so here see, if I take x is equal to 0, y is equal to 1, 0 by 1 is equal to 0. Next, if I take x is equal to 3, y is equal to 2, that means x by y is equal to 3 by 2. Now see, always a whole number. Is it a whole number? This is not at all defined. Is it a whole number? Yes, it is a whole number. Is it a whole number? No, it is not a whole number. That means always, the word see, always, no, not always, sometimes only. So that means this option is wrong. Never be a whole number. Never be a whole number. Never be a whole number means it is not a whole number, it is not defined, but here in this condition whole number came. That means this option is also wrong. Next, maybe a whole number, and it's not possible always. Yes. Okay, see, maybe a whole number. Let's check the third option. Maybe a whole number. This is not a whole number, but 0 is a whole number. That means maybe a whole number. That means option C is the correct answer for this question. Did you understand students? Each and every option we have to check, and each and every word of the sentence we have to know. Let's move on to the next one. The predecessor of 0 in the set of whole numbers. Yeah, very good question. Predecessor of 0, set of whole numbers. What are whole numbers? 0, 1, 2 and so on. 0, predecessor of 0. Predecessor of 0 is nothing but minus 1. Why? 0 minus 1 is equal to minus 1. That's why predecessor of 0 is minus 1. But in the set of whole numbers, in the set of whole numbers means, is minus 1 there in whole numbers? No. Minus 1 is included in integers, not in whole numbers. Whole numbers start from 0. That's why the answer for this one, minus 1, does it exist in whole numbers? No, it does not exist in whole numbers. That's why answer for this question is does not exist. If the question is in integers, we can directly say that minus 1 is the predecessor of 0. Okay, let's move on to the next question. Which of the following property is not valid in whole numbers? Okay, whole numbers. Let's see. Whole numbers. Let's revise the concept. Addition, subtraction, multiplication and division. Closure property, commutative property. Next, associative property. In addition, closure property and addition, yes. Possible. Subtraction, no. Multiplication, yes. Division, no. Commutative property, yes. No, yes, no. Associative property, yes, no, yes, no. This table we have to remember, okay, to crack the question very easily. So now see the question. Which property of the following property is not valid in whole numbers? First, see, closure property with respect to addition. Closure property with respect to addition. Closure property, yes, it is possible. Not valid, yes, it is possible. Next, closure property with respect to multiplication is possible. Closure property with respect to subtraction. Commutative property with respect to addition, it is also possible. It only does not possible. That means this is the answer for this question. Did you understand, students? We have to know each and every point of the concept. Okay, let's move on to the next one. In the set of the following numbers, the valid operation among the following is. Now we have to check the options one by one. See, 16 by 4 is equal to 4 ones are 4 fours are. 4 ones are 4 fours are. That means 4 is equal to 1 by 4. Is it true? Not at all. Second option. 16 plus 2, that is 18. 2 plus 16, that is also 18. That means this is the option correct. Okay. This one, 1 minus 8 minus 7. This is also correct. But minus 7 is not included in the whole numbers. The question is in the set of whole numbers. Remember, in set of whole numbers, this is not at all possible. Okay. This is also possible, but in set of whole numbers, minus 1 is not included. That's why it is not. Let's move to the next one. Multiplicative identity in whole numbers. Multiplicative identity. What is multiplicative identity? Take any number, that is original number. Okay. Multiply by 1, then the result will be original number only. That is called multiplicative identity. So 1 is called multiplicative identity here. Directly we can put the answer B. Next one, 2015 into 2016 into 2017 is equal to. It is associative property multiplication. Associative property under multiplication. Okay. 2015 into 2016 into 2017. Okay. Take any three numbers. In any order you multiply, then the result will be same. That is associative property under multiplication. Okay. See here, 2015, 16, 17. Where are 2015, 16, 17? 15, 16, 17. Everywhere 15, 16, 17 are there. But multiplication symbol, here plus, wrong. Here plus, wrong. Here also plus, wrong. This is the correct option. 2015 into 2016 into 2017. This is the correct option. Okay, students. Let's move on to the next one. The property related to the given operation. Okay. Which property did we use in this question? 2016 plus 0 is equal to 0 plus 2016 is equal to 2016. Here, whenever you say 0 and 1, whenever you see 0 and 1, that means that is identity only. Okay. So 0 plus 2016 is equal to 2016 plus 0, that is 2016, that is identity. No need to check any other option. If you see 0 and 1, that means identity only. Okay. Let's move on to the next one. The true statement among the following is very important. That means in this true statement, see, in the previous question we have seen false statement. Now we are going to check true statement. That means each and every option we have to check. Okay, right. Set of irrational numbers is finite. Irrational numbers, finite? No. Infinite. Set of whole numbers is less than. Set of whole numbers less than 100 is infinite. No. Finite and less than 100 we can count. Set of whole numbers is infinite. Set of integers is not infinite. Not infinite means finite. That means this is also wrong. Option C is the correct answer for this question. Okay, let's move on to the next one. If P into X is equal to P, then the value of X is equal to P into X is equal to P. Then the value of X is equal to X must be. Okay, this is original number. Let's see. This is original number. Original number is multiplied by another number that must be 1 only to get the original number. That means X must be 1 only. X must be 1 only. See here. 1 by 0 not at all defined. 0 by 1 that is equal to 0. 1 by 1, yes, 1 by 1 is equal to 1. This is minus 1. Therefore, option C is the correct answer for this question. Let's move on to the next one. Subtraction is commutative in the set of whole numbers. The statement is, already we have seen that. Check this table. Commutative subtraction. True or false? Not at all possible. So directly we can say that false. Subtraction is commutative in the set of whole numbers. That is false statement. Okay. If you know the properties, we can answer these questions very easily. Otherwise, we cannot. Let's move on to the next one. 12 by 6 divided by 6 is A. What is 12 by 6? Right here. 12 divided by 6 divided by 6. We have to use BODMAS. 6 ones are 6 twos are. That is 2 divided by 6. 2 ones are 2 threes are. That is 1 by 3 is the answer. 1 by 3. 1 by 3 whole number? No. Natural number? No. Fraction? Yes. 1 by 3 is a fraction. Okay. Integer? No. Answer is fraction. Let's move on to the next question. Multiplicative identity in the set of whole numbers is multiplicative identity. What do you mean? Whenever you see the word identity, two numbers should come into your mind. That is 0 and 1. This is additive identity. This is multiplicative identity. So multiplicative identity in the set of whole numbers is 1. That is option D. Let's move on to the next question. This is a direct question. Y into x is equal to y. Y is equal to 0. Then the value of x is value of x. Y into x is equal to y. Okay. See here, x must be 1 only. Y into 1 is equal to y always. But here the condition is y is equal to 0. That means if it is 0, 0 into 1 is equal to 0. 0 into 2 is equal to 0. 0 into 5 is equal to 0. 0 into 89 is equal to 0. Whatever the number you take in the place of x, the result will be 0 only. Okay, the value of x is, that means everywhere the value of x is changing. That means we cannot define that. That means does not exist here. Did you understand, students? If this condition is not given, x is equal to 0, this condition is not given, directly we can put the value as 1, because 1 into original number is equal to original number. 1 into anything is equal to anything. 1 into 5 is equal to 5. 1 into 100 is equal to 100. Okay? Okay, students. Let's move on to the next one. 2016 divided by 4 divided by 4 is equal to 4 ones are 4 how much? 4 5s are 20 and 4 4s are 16. Now 4 ones are 4, 10, 4 2s are 8, 24, 4 6s are 126. So the value is 126. 126 is a whole number, decimal, no, negative integer, no, fraction, no. Whole number is the correct answer. In this type of questions, we should know the basic calculations. Then we can answer these questions. Okay, students. Let's move on to the next one. Multiplicative inverse in the set of whole numbers is multiplicative inverse in set of whole numbers. What is multiplicative inverse? If I give you number 5, the multiplicative inverse will be 1 by 5. If I give you number 6, the multiplicative inverse will be 1 by 6. That means the value is 1, the value is 1. Here 1 by 6 and 1 by 5 does not exist in whole numbers. That means multiplicative inverse in the set of whole numbers does not exist. Okay, students? These are the questions which are related to worksheet 4 and worksheet 4A. Very, very easy questions if you know the concept. Otherwise, we cannot solve these questions. So that you have to understand the concept very carefully, students. Okay, students? Okay, see you in the next class. Until then, see you. Bye-bye.